Welcome to Ames Research Laboratory's Roof Video Series. We developed this series as a guide to help you maintain your building asset management plan for the long term. Today, we'll talk about why roof inspections are important. On this beautiful sunny day, we've gathered the facility manager, application contractor, and a quality control representative from Ames Research Laboratories to determine how best to assess existing conditions of the facility roof and determine if repairs or more extensive roof rehabilitation is necessary. Often roof care is limited to repair rather than preventative maintenance, which is not ideal for the building's asset management plan in the long term. By meeting together on this facility owner's roof, we can sort out the condition of the roof and determine how best to approach management of the roof's condition with Ames Research monolithic coating systems. As we walk the roof areas, we're looking for advanced signs of deterioration, general signs of aging, wear and tear, deferred maintenance, and general weathering of the roof system. As you can see in the video here, deteriorated roof conditions may not be visible, but concealed beneath the roof's surface finish. Close scrutiny and a bit of detective work is sometimes required. Extensive damage can be hidden just beneath the surface. Wood rot can be life-threatening. On this specific roof, we've identified drainage issues along valleys of the roof and are discussing methods of improving the drainage system by framing crickets on the roof. This will reduce the potential of standing water and improve runoff during an epic rain event. Old, previous temporary repairs are inspected. Split open surfaces and bubble deteriorated areas are identified, and options for either repairs or a new Ames monolithic reinforced seamless system are discussed. While we're on the roof, we also identify the need to involve other parties. For example, the project might require concrete cutters to add drain scuppers. A comprehensive roof inspection, identification of project scope, and involvement of all parties from the planning stage through to completion can lead to a successful project. Let us help you survey your roof's condition. We can help you develop your plan to protect and extend the useful life of your roof with Ames monolithic seamless coating systems without busting your budget. We are just a phone call away. Today, we'll talk about flat roof repair and EPDM roof installation. On the flat roof portion of this project, hazardous roof deterioration was pointed out during the roof survey and planning stage of the project. This video demonstrates the facility representative identifying and waving the Ames survey team away from hazardous parts of the roof, which are concealed by the existing roof top surface. The Ames survey team's consensus? Extensive suspected deterioration required removing the entire existing roof to identify then repair underlying damage in numerous hazardous areas. After full removal of the existing roof, the concealed damage became much more apparent, indicating the roof substrate had deteriorated to the point of dangerous rot existing in the underlying wood roof deck. This rot represented a serious life safety issue for anyone walking across the roof and further confirmed the Ames survey team's suspicions. As decking repairs were wrapping up, roofers continued by installing insulation board over vapor barrier membrane and sheets of fire-rated roof sheathing to meet current building code requirements. Safety cordoning was set up along the perimeter of the roof as a reminder to workers of potential fall hazards. Soft spots in the old roof are outlined and identified with notes written on the surface of the roof to remind workers of the hazard. The wood decking was replaced where deteriorated and new insulation board over vapor barrier was installed. The final roofing selection of EPDM rubber membrane was then installed by being fully adhered to the insulation board with contact adhesive. Although the cost of the EPDM rubber membrane was high, the choice was made to install the EPDM membrane at this flat section of roof as a durable base for future Ames energy-conserving reflective roof coatings. Ames roof coatings can be easily applied and maintained in the future. Along the center of the roof seams, sheets of EPDM are fastened together using two-sided adhesive splicing tape. This two-sided tape was installed along the edge of the EPDM membrane prior to placing the final strip of EPDM membrane down the center of the roof. A closer view of the work shows how a team of two carefully pull back the edge of the overlap at a seam while simultaneously installing the two-sided EPDM seam tape on the underlying lap. The team grows to 3 men to pull out any minor wrinkling in a seam tape before fastening down. This portion of the work can be labor-intensive and requires close attention to details. A final check with a seam roller takes place. Then the lap is laid out over the seam tape and smoothed to remove any air pockets and provide continuous adhesion. An alternate method of fastening lapped seams is shown here using contact cement splicing adhesive in lieu of two-sided seam tape. The upper flat roof total replacement is now finished and will eventually be top-coated with an Ames energy-efficient reflective finish that will cool down the roof and reduce the heat load transfer to the building interior. As always, Ames Research Laboratories is here to discuss options that are best for your specific roof issues and your bottom line. We recognize that roof solutions are not always a full roof tear-off and replacement, but when the underlying damage is excessive, we will recommend what is best for you. Today, we'll talk about flat scuppers, crickets, and TPO over crickets. During the plant survey, it was determined the drainage valleys that existed around each section of both domed roofs had extremely poor drainage patterns. This caused water to bottleneck before making its way to the various roof scuppers. This poor water flow condition caused scuppers to overflow and water to accumulate on the roof. This accumulated water added excessive weight to the roof deck along much of the low areas of the roof and increased the likelihood of leaks. The poor roof drainage patterns were corrected by installing wood-framed crickets along the length of each domed roof. The varying height and angle of the new cricket framing changed the way the runoff water flowed down the roof. This improvement to the drainage patterns allowed repositioning and resized drain scuppers to work more efficiently. The inspection of roof scupper drains revealed that some of the scupper drain areas had deteriorated wood framing under the existing roofing materials. This necessitated removal of all the overlaying roofing materials to expose the extent of the deterioration. Exposed areas of wood rot were removed and reframed with new wood and decking prior to beginning installation of new roof finishes. It was also determined by calculating area historic rain events, the scupper sizing was not sufficient to adequately allow drainage of the surface area of the roof without accumulation of excessive water on the roof. This was done by utilizing historic water data obtained from the National Oceanic Atmospheric Administration and almetsat.com, who track and archive weather events across the United States, including rainfall patterns. International plumbing codes and recommendations were then used to calculate anticipated water runoff requirements for this specific roof. Scuppers and scupper openings were enlarged to meet the drainage demand. Additionally, new TPO roof membrane liners were installed uniformly around the new crickets and drains in the high water accumulation areas of the roof. Once the repair and replacement work was completed, it was time to clean up the remaining roofs and move into the next part of the work, which involved applying roof coatings. As always, Ames Research Laboratories is here to discuss options that are best for your specific roof issues and your bottom line. We recognize that roof solutions are not always a full roof tear-off and replacement, but when the underlying damage is excessive, we will recommend what is best for you. Today, we'll talk about cleaning and beginning BlueMax application. As we pre-clean the roof surfaces, you will notice that we are using a wheeled trolley assembly which controls debris. You will also see we have set up 2 separate pressure washers. The second pressure washer has a handheld spray wand that can be used both for large surface areas and also cleaning in close spaces and along roof edges. For this project, we have selected a Graco 833 roof spray rig capable of applying the roof coatings selected for the project. There are many sprayers capable of spraying our roof coatings. Additionally, we are happy to review the customer's existing sprayers to determine if they are rated to spray our material. To save on manpower costs, we will use materials in a large tote container holding 250 gallons of material. This saves labor time versus handling a large quantity of smaller containers. Now that the roof is clean, we proceed with application of a stripe coat of Blue Max along the seams of the existing roofing. This is done to pre-seal seam edges before applying a first full coat of Blue Max. As we proceed with the first full bond coat of Blue Max, we pay attention to details such as roof flashings around vents. This first coat of Blue Max material will provide excellent adhesion to the existing roof surface, providing a bond coat for the subsequent coats of material we will be applying. By spraying a consistent grid pattern across the roof and using an overlapping spray pattern, uniformity of the coatings film is controlled. To assure proper thickness, a technician is checking the millage of the material being applied. The gauge used is provided free of charge by Ames Research Laboratories. Selecting a pump to fit the size of the project enables the coating technician to quickly and efficiently apply a large volume of material in the proper thickness to the roof surface. Material can be applied as fast as a man can walk. The coating technician here also has a hose handling assistant keeping the excess spray hose away from the spray technician, enabling smooth movement across the roof surface without tripping or slipping. One of the crew takes time to monitor the level of the Blue Max in the tote to ensure the pump does not run out of material during the course of the day. The bond coat of Blue Max will need to dry overnight before the next step in the installation process is begun. As always, Ames Research Laboratories is here to discuss options that are best for your specific roof issues and your bottom line. We recognize that roof solutions are not always a full roof tear-off and replacement, but when the underlying damage is excessive, we will recommend what is best for you. Today, we'll talk about Day 2 of Blue Max application. After the bond coat of Blue Max has dried overnight, the next step in the installation process is the embedded fabric layer. This layer is started by unrolling and cutting a piece of fabric and followed by pre-spraying a section of roof slightly larger than the fabric. Once the spray technician has applied the wet material to embed the fabric handlers first position the fabric over the wet material, then carefully place the fabric onto the wet material beneath. Now that the fabric is positioned, half of the fabric handlers pick up paint rollers and begin to anchor down the fabric into the wet Blue Max beneath the fabric. The other half of the fabric team continue to hold the fabric straight, avoiding wrinkles. As the fabric roller team roll down the fabric into the wet Blue Max beneath, the spray applicator supplements with additional wet Blue Max material on the surface of the fabric to fully saturate the fabric. The pre-spray, fabric embed, and saturating fabric process is completed in additional overlapping passes across the roof surface, panel by panel. After the layer of embedded fabric has dried overnight, the crew examines the fabric reinforcing layer for possible additional attention. The crew looks for loose seams and inadequately saturated fabric. Now that we are assured the fabric reinforced layer of Blue Max was properly installed, we move on to applying a final coat of Blue Max waterproofing across the entire roof. For each coat of material we apply, there's always time to stop periodically and check to ensure that material is being applied at the recommended thicknesses. Ames coatings are designed to perform best at recommended product and system application rates. These material rates are easily checked with the free Ames mill gauges available from our sales staff. As Ames Blue Max is applied, you will notice the material dries down from a translucent light blue to a more opaque dark blue color. This helps you identify your spray patterns as you move systematically across the roof, applying the material. 3 coats of Blue Max roof waterproofing will be installed as a base layer on the roof project. The next step will be application of the Ames top coat materials. As always, Ames Research Laboratories is here to discuss options that are best for your specific roof issues and your bottom line. We recognize that roof solutions are not always a full roof tear-off and replacement, but when the underlying damage is excessive, we will recommend what is best for you. Today, we'll talk about applying Ames top coat materials. Now that the 3-coat reinforced Blue Max roof waterproofing materials have been installed as the base layers on this roof project, it's time to begin application of the Ames top coat materials. The first coat is applied in a systematic pattern across the roof. Notice the good spray practices being employed with 2 hose handlers in close quarters. As with previous coats, the crew pauses to check millage of the finish coat, to verify thickness, and adjust spray speeds accordingly as needed. Back the next day to apply the second top coat finish of Ames white roof coating. Notice that the spray crew is applying the second coat of finish in a crosshatched pattern perpendicular to the first coat previously applied. This is good spray practice and provides a more consistent uniformity in coverage of the materials. We recommend this practice whenever possible. As each project has a beginning, so does each also have an ending. A successful project ends with inspection of the finished work by all involved parties. We see here the owner's representative and the application contractor getting together to inspect the finished product. The inspection team slowly and systematically walks the roof, checking the integrity of the contractor's installation work. Inspecting the roof on a sunny day highlights the reflective capability of the Ames top coat, while the building below enjoys cooler temperatures as a result. Excellent place to have your sunglasses on. The team is in agreement. Another Ames roof project successfully completed. Time to move on to the next roof after a successful project completed with Ames Research Laboratories roof coating systems. As always, Ames Research Laboratories is here to discuss options that are best for your specific roof issues and your bottom line. We recognize that roof solutions are not always a full roof tear-off and replacement, but when the underlying damage is excessive, we will recommend what is best for you.